An unknown compound has the formula of CHE166 When 0.200 grams of compound is burned in oxygen, you isolate 0.293 grams of carbon dioxide and 0.120 grams of H2O, which is water. What is the empirical formula for the unknown compound?
The first step to tackle this question is to set up the equation to be able to see what you are working with, that the compound is burned in oxygen, and therefore it is a combustion reaction. Don't forget that oxygen is a diatomic, so we always write it as O2. First, we are given CO2 and H2O. They include carbon and hydrogen, which we are trying to find in the compound itself. We will begin there. Carbon's molar mass is 12.01 grams per mole, which can be found in the periodic table right here. And hydrogen's molar mass is 1.008, which can be found over here. The overall molar mass of CO2 is equal to 44.011 grams per mole. We get this number, the molar mass, by adding 12.01, the mass of carbon, plus the mass of oxygen, which is 16 times 2, because it's O2. And then we do the same thing for H2O, which is equal to 18.016 grams per mole, because hydrogen has the mass of 1.008 times 2, because it's H2, plus 16, the mass of oxygen, and then that gets you to 18.016. Then we find what we were trying to find is carbon and the hydrogen. So we take 12.01, the mass of carbon, and divide it by the molar mass that we just found of CO2, 0.011, and you multiply by what is given in the problem, 0.293 grams of CO2. And then you get 0.07996 grams of carbon. And then you do the same for hydrogen, 2.016, which is just 1.008 times 2. And you put it over the molar mass of H2O, 6, and you multiply it by what is given in the problem, 0.120 grams. And then you get 0.1343 grams of hydrogen. The entire mass that is given in the problem is 0.200 grams. So you take 0.200 grams and you subtract it by what we just got. Minus 0.01343, and then we get grams of oxygen.
Then we continue to find the moles of each element using the formula N equals mass over molar mass. Remember that this N means moles. Then we take the mass of what was found and divide it by the molar mass of each element. For carbon, it is 0.07996 over the molar mass of carbon, which is 12.01. Then for hydrogen, it is 0.01343 over 1.008. And finally for oxygen, it is 0.1662 over 16. Keep in mind that on top it is what we found, and on the bottom it is the molar mass of each element. Moles hydrogen. And lastly, for oxygen, it is 0.00666 moles of oxygen. Now, we divide by the smallest number of moles. In this case, it's 0.00666. After dividing, you get for carbon 1, for hydrogen 1.999, which can be rounded up to 2, and for oxygen you get 1. This means the empirical formula is carbon, hydrogen 2,